Here are the two exponential decay equations again, and we're going to imagine that we've got a sample of radioactive material and a stopwatch. At the instant we start the stopwatch, this is how many unstable nuclei we have in our sample, and this is the activity of the sample, the number of decays that are happening per second. After this much time has passed, this is how many unstable nuclei we have left, and this is their activity, the number of decays per second that's happening now. If what you want to work out is how many nuclei you've got left, or what's the activity at time t, this equation's reasonably straightforward to use. So we're going to dive straight in with a question. There's a little bit of moles first, just to make it a little bit different. And then here's your activity that you're calculating there. Right, actually it does follow on from the previous question, so you are going to need those values as well. Okay, so what they're saying is that this chemical they've given the patient, FDG, it's not all the radioactive elements. So we've just worked out how many nuclei of fluorine 18 we had at the beginning, but we're being told that that wasn't all of it. So that was only 9.9% of this FDG. So the first thing we're going to do, I'm going to assume I've taken my own advice here and I've written these two formulae down when I got into the exam. So the first thing we're going to do, if that's the initial number of nuclei that we had, we're going to work out how many moles that is. And we get this very tiny number. And then we're going to use the other formula because we've been told the number of kilograms per mole. So this is the mass of fluorine 18 that we have at the beginning. But that is only 9.9% of the total FDG. And so this is the initial total mass of the thing that was injected into the patient. This next bit is much easier because all we have to do is convert that to seconds and put it in there, and then the initial activity we had right up there at the top. Putting all the numbers in, we get an activity of 220 megabecquerels. Now notice, a typical PET scan takes 20 minutes. At the beginning of the PET scan, the activity was 250 megabecquerels, and at the end, it's 220 megabecquerels. That's about right because during the scan, you need enough radiation to be coming out, so it hasn't dropped that much, and that's what we would expect.